Yeah, I think what you said is absolutely right, and I don't deny the existence of the very, very good third person, explanation and the science, which has worked so far really well. But
Sure. Yeah.
that just doesn't work for the explanation of the at least quantum theory and also many other
Mm,
cases where we know that the non-commutativity is at play.
mm,
The essence is that the effect of the measurement or effect of the observation actually affects on the state of the system. Once you have that, then you just can't have this, God eyes point of view because that eye itself has an effect on the state of the things that you
mm,
that
mm,
observe from there,
mm, mm, mm,
which may be just inconsistent with another view, from my view of the world, you know,
mm,
and
mm,
so that perspective or process or things that we do rather than how things are. I
mm,
think it's gonna be eventually, uh, kind of conceptualized, needs to be reconceptualized from this type of the viewpoint to take into account of
mm,
this viewpoint and also effects of the observation and the forefront of this, science or scientific revolution is, at the consciousness side and also probably
mm,
measurement related, quantum theory side. But the quantum theory side
mm,
seems to be, according to my colleague, is already closed. So I think it's really the observer or measurement or this effect, how this affects on consciousness is the one that we need to understand.
mm,
But I wanted to say one thing about that, abstract and also concrete. This
mm,
is something that I'm also thinking about, writing at least as an essay or something. Because you
mm.
also talk about this in Yoneda
Right.
Lemma video as well, right?
Yeah.
I think this math or abstract and also nature or concrete has a relationship of the adjunction,
Mm,
which is in a sense loose kind of sameness between them.
mm,
Like a platonic kind of idea is that if you have some kind of model here, then that is actually projected into this particular thing in nature and so on, right? Or some
mm,
kind of
mm,
mathematical equation, let's say if we call it MA or whatever, that's realized in nature in things moving
mm.
or whatever.
Yeah.
And
Yeah.
then it's always the case that people think this is more fundamental than this,
Yeah.
right?
Yeah.
But I think that's probably not true in the end.
Mm,
We need to have both this direction of arrow and also this direction of arrow as a functor.
mm,
And each of them has to be coherent because when we extract some kind of concrete thing into abstract, it's never the case that there is only one way to go there,
mm,
right? Seeing the nature, you know, you can explain certain aspect of the nature if you choose that's what you want to explain, and then you get
mm,
some kind of equation about that. So I
mm.
always find it's very weird to talk about like the fundamental equation or the master equation or everything or something like that because
Mm,
it doesn't give us the particular explanation that we want to get
mm.
for particular phenomena that we observe. And this selection of the thing that we want to explain is coming from this side. You need to
Yeah.
do it at the concrete level, and then you get some kind of abstraction. and the abstraction is applied to this concrete setting. So in a sense, abstraction is, in a sense, contained within how you choose, how you cut the things in the concrete world. It's not existing in a vacuum.
Right. I think my first reaction to that is, I think why people think that the abstract side might be more fundamental is that you can find within the abstract world, you can explore it by itself, right? So you do not have to just look at the concrete to get to the abstract world. You can explore the abstract world without looking at the concrete. And a good example of that would be, complex numbers, right? The square root of -1. You cannot observe that in nature, and it didn't play a role for describing nature and abstracting from nature until quantum physics came along. It was a pure discovery looking within mathematics. And then we actually found out that it's useful for describing nature in quantum physics and other ways. But it does seem like there is a realm that's not abstracted just from nature, but there seems to be, almost like a platonic other reality. And yes, they seem to interact, but the fact that we made mathematical discovery sometimes before we then found the how it boils down to in the concrete, that is, I think, why people feel that it might be more fundamental.
Maybe that you're right. I haven't thought about this, but it may be the case. This is another kind of conjecture, but the mathematician sort of idea itself, this itself becomes a kind of concrete, and then another level of the abstraction is coming from this level when they think as a concrete, and that's actually also the product of the brain and the mental function, right? And then it gets to this abstract. So you also the concreteness also comes at a quite arbitrary level of the things, like we can't really see the molecule, and we can't also see the infrared, and is it actually a concrete or abstract or finer resolution and the things like that. So this is a possibly like quite complex stratified and things include, which is included by the original thing, kind of idea. I don't know about this, but this I really think this idea of the adjunction in category theory between the abstract and the concrete feels quite an important thing to think, in more depth.
And why do you think it's an adjunction, not an isomorphism? Could there be an isomorphism?
No, that's not. But importantly, my sort of the category theory master, Steve, always says that the adjunction is a local isomorphism. So if you look at in a sense, this kind of thing, and then at this area, you can find exactly the coherent kind of relationship between this and this, and then that's the part where you can go from A to B, and then coming back from B to A, and the result is exactly the same as A. This is a definition of the isomorphism, and then you need to go from B to A and A to B, and then that's the same as B itself, right?
Right.
And this local isomorphism is in general the same as this adjunction, but there's more to it, right?
But okay, so this is really interesting. But with what you drew right there, right, you could say, well, but there could be okay, you found an adjunction that might be, maybe like Newtonian law of physics, right? But there could be an isomorphism that could explain all of that. And isn't that what science is after? So far we just found the adjunctions, but there could be an isomorphism.
Yeah. So that's a kind of the, if I realize what we wrote in 2016 is exactly that. trying not to find the isomorphism from the beginning, but start with a looser level of the sameness and then try to get to the isomorphism eventually. But in reality, adjunction is, in many cases, the highest level we can attain. And in the quantum physics, the Bell inequality case, I think this is the thing, like, from observer A and observer B, we can locally agree exactly like this, but that's inconsistent between A and B globally. Like, in the case of the A observing X is always 0 correlate with B observing another thing like Y as 0, which is correlated with A observing Y to be 0, but that's actually correlated with B observing X to be 1, and that actually predicts A observing X as 1. And then every time what you can do is pairs of the observation. Like Alice and Bob observing X or Y. And then if Alice observes 0, then Bob always also observes 0. And then this is also the case locally, always coherent, correlated. And this is also correlated. And then this is also correlated. But then at this point, you realize, wait, if this is the kind of, if there isn't a God view, this is out. Logically, it doesn't make sense, right?
Yeah, I think I get it. What you're saying is that the isomorphism assumption is basically the same idea as the God view.
In a sense, yes. In some certain cases, and it's very difficult to demonstrate. And it may not exist in many cases.
Yeah, that's interesting.
Okay, maybe it's already, we talked quite a bit today, so maybe it's good to stop here, and then we have just a little bit of chat from now.
Sure, sounds good.
Okay, good.